Today, with the Internet of Things, new mass-market services may be offered in different areas such as smart city, health, agriculture, and industry of the future. The difficulty to build these new services comes from the number, the dispersion, the variety, and the volatility of communicating objects. In addition, these objects produce data with variable levels of quality and abstraction, and which are sensitive with respect to privacy concerns. To facilitate the development, the deployment, and the execution of these services, the INCOM project offers design process and generic software infrastructure to transform and route, but also to interpret, qualify, protect, and filter context data derived from collected data. The FORMI demonstrator is a set of services for smart cities. It is intended for a user of multimodal transportation who mixed pedestrian, bikes, and especially free access bikes, personal vehicles, and public transportation modes. FORMI also offers service for smart shopping in the city. This FORMI demonstrator provides ubiquitous and real-time access to all kinds of city data provided by the Internet of Things. INCOM provides 3 design processes supported by a set of frameworks. The first design process is for the design of the dissemination platform. The second one for the design of the collectors of IoT data. And the third one for the design of IoT applications. The design processes include a definition of logical zones to limit the broadcasting of data, data quality criteria, contracts to ensure privacy, and multi-scale deployment descriptors.
Amélie comes out of her office. She goes to her gym. She asks for a route to FORMI, which suggests to go there by bike as a first choice, otherwise by bus.
Based on multiple data, such as the weather, Amélie's agenda, her location, her preferences, and her situation, the system suggests to go by bike. INCOM is involved here in the detection of situation thanks to a reasoning and a machine learning engine able to find the current situation of the user among a set of existing situations. It is also able to detect new situations and propose suggestions according to such new situations. INCOM allows users to define rules to protect their privacy by indicating with who, for what purpose, and in what situations they agree to share information.
After a sporting activity, FORMI has knowledge from her agenda that Amélie should go to the cinema, where she has an appointment at 8 p.m. with a group of moviegoers. The service detects a pollution peak. Accordingly, the application suggests Amélie to take the bus, and thanks to the FORMI guidance service, Amélie goes to the bus station.
INCOM provides the means for modeling the indicators of quality of information, program the estimation of this quality, and the selection of data based on the quality. As well, the management of the quality of the context information is supported since its acquisition by sensors up to its consumption by services through different phases of transformation and selective routing. In the privacy choice that Amélie has defined, she accepts to share her location with the other participants in an activity when they are close. The rest of the time, the location of Amélie is not visible.
Sébastien, one of the moviegoers, is in the bus 88. FORMI detects that Sébastien is in the bus arriving in 5 minutes. Amélie therefore decides to wait for this bus to meet Sébastien.
INCOM provides the means, abstractions for expressing multiscale contraints for the deployment of software components. To archive what has been seen so far, it has been necessary to deploy the various software components. For this, INCOM processes a deployment process. First of all, In parallel with the design of the application, the engineer expresses in a dedicated language deployment properties without knowing the whole deployment devices. A deployment plan is generated just on time according to the devices actually available. The deployment is then conducted. In this phase, the components are installed and activated. Later on, the system detects a new device in accordance with the specification, here the appearance in a geographical area. It adapts then the deployment automatically.
Thanks to FOMI, 5 moviegoers among the 10 expected have already met on the road.
Amélie has a lot of friends, and it is not usual for her to be aware continuously of all the whereabouts of each of them. Conversely, Cyril and Corina, friends of Amélie, do not wish to show their location when they are not close or in potential immediate social interaction. The application shows only on screen the moviegoers, which are in the same neighborhood. In this demonstration, to distribute and filter context data, the city of Toulouse is covered by a network of brokers using the MEDEPS frameworks.
As they are early for the movie, they emit the wish to go for a drink all together. A new service, designed with income, intervenes with new filtering and interpretations. Via one of the FOMI services, the list of cafes close to the cinema and with available tables is displayed, so they can choose one of them and order their drinks. They arrive in the selected cafe where they are expected and their drinks served. Income proposes design processes and generic software which allow to build efficiently new services for the IoT. First of all, we have Musca, a framework that allows platform providers to define logical zones that are then used to limit the dissemination of information on logical zones previously defined. Dissemination is provided by MUDEPS, a multi-scale distributed event-based system. Then we have music, which allows the automatic learning of situations and the identification of these situations. With COSIM, MuContext and Capuer, bipartite contracts are defined, allowing to express constraints on quality of context and on privacy. The framework Muscadem realizes a dynamic deployment of software components. Thus, thanks to Income, suppliers of IoT services accelerate the process of development and deployment of their services.